Yeah, thank you. It's a real pleasure to be here, and I can speak to the Minister's talk earlier. This is my second visit to Scotland, I think in 14 days, so it's definitely a growing collaboration and place of interest for us. There's no clock in the room, so you'll have to forgive me. I will do my best to stick to time on the little tiny one. I wanted to take you on a bit of a journey today, because that's what one can do when you have the liberty of giving a keynote, right? And before I dive into the depth of my slides, I'll give you some of the history. And so Arno, Dr. Arola and I work in a group we call the Cybersecurity Analytics Group at the Department of Computer Science in Oxford. We also work with the Global Cybersecurity Capacity Centre, which is where we do our policy work, national, regional work around the world. And in a way, our journey is as you would expect. So parking the policy work and focusing on what we do in computer science, we do a lot of what you might imagine a bunch of computer scientists might do in cybersecurity. And some of the things we've looked at speak to the breadth of programme in this conference. So we've been interested over the years in working out what's the onward consequence for a mission. Should we get some warning of a potential threat? What does that look like? What might happen to the processes? What might happen to the routines? How might that attack propagate? We've looked at how developing different logics to take account of different kinds of risk controls or different kinds of security requirements, the obvious CIA ones. We've worked on visual analytic techniques, worrying about how can we help analysts engage with that kind of situational awareness, and how can we be sure that it's actually having an impact in terms of the practice. We've worked in other areas to do with social media. We got involved when the press went mad a number of years ago, worrying about the consequence of somebody, the wife of a very senior person in government, posting information about family holidays online. Was that really introducing a vulnerability? And we were hoping to disprove the hype, and our work indicated that the situation was far worse than anyone had potentially realised when you look at all of the art of the possible. And I guess that then evolved, and Arno and I both worked personally on this, into looking at what identity vulnerability online really is. And so we've been concerning ourselves with the full remit, from access control, new kinds of threat detection. We've done years on understanding insider threat and how we might use anomaly detection to look at that and see it coming at us earlier, all the way up to what does it mean to really properly consider human beings as integral to a system, how do we model that, and how do we communicate the outcome of all of this so that we have some form of situational awareness that helps all of us do better. And then about 3 years ago, so we're working on this, and about 3 years ago, I was sat at a conference in the States and had the benefit of hearing one of the chairmen of one of the world's largest insurers talking about cybersecurity. And of course, it's a massive growth area for the insurance industry, cyber. And what I had never heard before and had never understood before, actually, was how the world of insurance helps us take risk and do things differently. It introduces a new kind of control. And the cynic in all of us might say, okay, that's very interesting, and where you can quantify the loss from a cyber event, and all that matters to you is somehow financing that so that you can carry on and work through, then yes, that has a role to play. And some people would say, but there are always going to be instances when the game is over, right? And that may be true. But nevertheless, there is something in this. And it cannot be wrong, because what has emerged since is the truth of the matter, a massive growth. And if you study, and I know some of the people in the room do, you look at today's events, what's really happening, what kinds of attacks are emerging, and how it is that organisations are staying in the game, you will of course be drawing the conclusion that the practice of how you handle an attack, what you do in response to it, how you communicate around it, what your technical teams are doing in terms of investigation, how you learn from that, how you achieve resilience, is actually crucial. And so no matter where we're working, whether we're in the prevent space, trying to lock down the vulnerability and reduce the attack surface so none of this can happen in the first place, or whether you're someone that's working over here, which is in the world of, yes, but there's humans in the systems, it's not just about the technology, there will always be attacks that get through, and therefore what we have to do is detect and make sure that our response is mitigating the harm as much as possible. What I wanted to communicate to you today and to describe to you is some of the work we've been doing, which is how do we glue all these pieces together? Because for many years, we in the cybersecurity industry have talked about you're only as strong as your weakest link, or cybersecurity is all about layers. And then you look at the evolution of our standards and our frameworks, and they talk about lots of different controls coming together. And then you talk to people who are charged with actually delivering cybersecurity for some of our world's biggest organisations, and you get a feeling that there's an art form there. And so it feels much more, doesn't it, like an orchestra. And you have to know when to bring in the different parts. And so when we sat down and said, okay, so if you think about cybersecurity science, as we were as a community, what should we really be doing? Because there are so many sciences involved in this. There's mathematics, there's computer science. If you're working in hardware, you're into materials science, you're into engineering science. If you are concerned about really understanding the consequence of a person in the system, you're talking to psychologists. If you're starting to think about how we deploy controls across an economy, you're talking to economists, you'll be talking to sociologists. There are so many sciences and so many scientific methods that we have to bring to bear in order to conduct our orchestra, that we've just began to think, okay, well, there is a space here for understanding where we might need to put a bit more rigour. And it's in that glue, in bringing those parts together. Because so far, we as a community, we've been working on knowledge and gut instinct, and something that has not been given the rigour and the consideration that perhaps it ought to, if we're going to benefit from the rigour and the science that sits inside each of these parts. And so this is the journey, and I'm going to give you a glimpse of part of our journey, because we're on it, that we've been going on. And for us, this is actually about, yes I can drive it, great. Understanding what's left in terms of risk once we've done our best. So we accept we've assessed our risk, we've made some choices about controls, we are benefiting from multi-factor authentication, we're benefiting from recent breakthroughs in biometrics, we're doing our best with intrusion detection, we have bought the latest algorithms, we are locking down our hardware, we are staying ahead of the encryption war games and using the toughest encryption. We're worrying about all of these things, but still we have risk. And so really, the name of the game surely is not just to do all those bits and pieces, but to work out, once you've done them, what do we still face, given that we're using these controls? And how might it not be aggregating? So we might have the responsibility for a single organisation, and we have to worry about that. But equally, we might actually have the responsibility of worrying about a sector, or a critical national infrastructure, or a region. Or we might be in a supply chain which is truly global, whether that's energy, or transport, or food, whatever it might be. And so we might also be worrying about, how is this aggregating? Is there commonality in residual risk, because there's commonality in technology, and practice, and humanity, that a threat, a well-organised threat, could exploit that would create a serious consequence for us, not dissimilar to the kind of aggregated risk we saw in the financial systems many years ago. Could that be emerging in cyber? And so you can see how this is also of interest, is it not, to the insurance industry. And we are benefiting from a very close working relationship with them, because they need to write good books. We need to be able to insure ourselves against losses. There are times when that is the most sensible move to make. But we need that sector as a whole to also be understanding how these things are coming together. And so we started on this journey, and we started looking for evidence, data, on the effectiveness of these different kinds of controls that we all work on and all use from day to day. And the consequence of this was, it's very, very limited. So although we understand there are certain things we should be doing, in terms of the data, the empirically observable data, it's not there, which means we have to use good social science currently to extract what good practice is, but maybe that's not enough for us when we want to really model the glue. And on this slide, what you see is the result of a survey with chief security officers. And don't really have to read it. The main point of this is that they're using this stuff, they have a view on what works, and yet there is no data out there. And then we took that further. We said that's really interesting. It's not unsurprising because we know as a discipline we're really new in the kind of big scale of human knowledge. Cyberspace is new, and the study of securing cyberspace and understanding what's going on and what harm is even newer, and therefore it's not surprising that we have massive gaps in our knowledge. So then we said, okay, this is interesting. So let's pick the top 20 controls. We picked the CSC top 20 of acceptable, this is what you must do if you're an organisation. Let's look at those. Can't find the data. It's in the knowledge, though. It's in the practice. But then we said, how do they relate to each other? Are these things really things you can treat separately? So is our problem just one of saying, okay, let's just focus on this control set and let's introduce some rigour. Let's tool it up, maybe build the right simulated environment, build the lab. Let's go to the organisations and try and build the evidence that this is why one of these helps you. That's why you should spend £1 million on it this year. And this is the kind of harm avoidance or risk mitigation you might expect to get. But the world is complicated, and what you see there is a mapping of the interdependencies between the top 20. It doesn't really matter which one you're looking at. As it turns out, the most well-connected in this graph are number 6, 16 and 17, which are things like maintenance and monitoring, audit control kind of things, access control, and then skills assessment and education. It's unsurprising. But it's very important because it has consequence. When you are directing your orchestra and you're thinking about how you invest, you can't think of these things in isolation. It means you invest in one thing, you invest in many if you want to be effective. And so then we thought, okay, well what we actually need is a model. We need to have a framework within which we and other people who are gathering this data and this knowledge can start to glue this together. We need to understand how assets and controls might have an impact for an organisation and what the consequence is. What is the value at risk once you've deployed these controls? And so this is our proposed model that we began with. And so what you see in the blue, of course, is the stuff we're all very used to talking about assets. But bear in mind, we take the broadest view of an asset. So an asset is not just technology here, it's not just information. It might be a business routine. It might be the ability to sell, or the ability to manage HR, or in a military environment, a mission. It would also include people as critical assets. It might also include your brand, or anything where harm might manifest. And so then the yellow, of course, this is where we represent the broad understanding of harms that can arise in our cyber systems. And that then has a consequence because once we understand how the controls are impacting both the assets and the harms that might manifest, then we can start to say something, can we, about the residual risk, the value at risk for a particular organisation once these things are in play. But of course that, as you will all be saying to yourselves, is all very well and slightly oversimplified because any organisation is exceptionally complex. And in actual fact, we all know, don't we, that if you were to sit down and say, where are all your assets for your organisation, well, you wouldn't believe anyone that felt they could write that down. And that has been the status for many years. I remember when I used to work in the industry and we used to work on accrediting systems as secure, we did so fully in the knowledge that that system, once deployed, was going to change within 4 weeks. And so we know, don't we, that what we actually need is a more runtime, continuous accreditation or monitoring of our security postures. So this, what you see on the board, is this kind of oversimplified, let's just think about how this might work, version of an asset base. And the reason why you see these different pools, these 5 different pools, is we're just trying to pick apart in our head, what do we really mean by assets? And so there's enterprise assets at the top, profitability, if you're a commercial company, knowledge for some people, intelligence perhaps, and we have routines and people, information systems and physical stuff. And all of these things are related. Some things depend on others. Some data is contained on a piece of hardware. Some routines are critically dependent on staff or people, your ability to operate. So we're assuming that there's no longer a black box, but of course one can make templates and abstractions. So already we can see, I have to talk really loudly, we can define a bunch of relations across these nodes in our system. So here we have interactions and containment that depends upon, and that can be given as semantics, a formal semantics that would enable you, should you wish, to use graph analytics to reason about this. You could automatically generate one of these, possibly off of instruments lying inside your systems. Be hard to do the human bit. Maybe we need to talk to people. But anyhow, we could give rise to one of these. So this convinces us that it's possible to form an abstract model about what matters and what are the moving parts. And so how would you bring that together to think about the glue? Well, in particular, the harms. So here we have a file server containing stuff, some customer data containing stuff. It has a relationship, and we think about certain harms. In this case, unauthorized access to data, that's an initial risk that obviously pops out of risk assessments, but it can trigger other things. Here we have regulatory fines, and we have damaged reputation. Well, there's a flow through from that. Damaged reputation you might care about for its own sake, but you will also care because one of the things it can do is reduce your customers. And there's similar views you could take if you were thinking about political status in the international stage. So it doesn't just work for commercial enterprise. You could do a similar thing for your home and for your family. You'd have different answers about what you really care about. But the important thing to think about here is there's immediate and obvious kinds of harm, and we deliberately talk about harm and not risk here, that will pop up on risk assessments. And by risk assessment, I mean that long table of things, where we say there's a threat, there's a vulnerability to this asset, the likelihood of that threat actually exploiting that vulnerability to attack me is this, and the consequence of my enterprise is that. And we come up with our prioritised table, do we not? And against that, we decide what we're going to do with these amazing innovations that we're all going to be talking about in the next 48 hours, which are those we should be using as we orchestrate our cybersecurity. Well, here we're trying to not think in such a two-dimensional linear way in terms of lists of risks. We're trying to think about the sum of all risk, the harm, and all the different kinds of harm that might arise. In actual fact, the triggering of harms that might be considered in a military sense the second and third order effects, not the immediate effects of the enterprise. So we began to think about that and to put some semantics about that. And once we've done that, we can start thinking about controls that we will work on. And some of those controls are obviously there to protect specific assets. If, for example, I walk around with an encrypted hard disk, I'm doing it to protect the data on my laptop from a breach of confidentiality in the first instance. But I'm doing that because I feel that the breach of confidentiality in the data on my laptop could give rise to lots of harms that I'm concerned about. And so that's how we're trying to bring this glue together. But there are other pieces of control that we will be talking about at this conference that actually are very focused on limiting the growth of harm. And the one that you can't read here that I'm pointing to is to do with monitoring and incident response. So that's the control. It's not there to attempt to prevent, although if you had the world's best team, you might hope they can jump on it and pull the plug on it in a very abstract way well before any harm has manifest. But nevertheless, there's something to jump on, which means somebody's knocked on the door and they're halfway through. So some of our controls are actually, in all honesty, about trying to control this ripple effect of harm. And then once we have an understanding of what our system looks like and the kinds of losses and the harms that might arise, then if we can see there's some probability of us being attacked in that way, and taking account of the probability or not of our controls being effective, then we can say something about the value at risk in the face of those controls. And that's telling us more about where we stand, our real security posture, given the current practice that we're engaged in. So we started building tools to simulate this model, to reason about this model, and more recently to literally instantiate this model for certain scenarios. And one of the spaces where we as a community lack real data is, as I said, on the consequence and the effectiveness of control mechanisms. And so when we talk about residual losses and residual likelihood, we have to make some assumptions about the consequence of using one of these control mechanisms on risk, on the quantification of harm. So, is it effective in removing your attack surface? Is it designed to remove attack surface? Maybe not. How is it designed to work? What is the likelihood that it will be effective? And that boils down, does it not, to practice as much as anything. So if you look at, let's think, where are we? We're 2018. So 2017, Equifax. And that whole thing that played out in the press. And what turned out, of course, was that there's a vulnerability that's been exploited for which there was a patch made available months before the actual attack took place. And so if you were to build a model of a system that assumed that we all patch immediately every possible vulnerability, and therefore, as soon as you found an exploitable point of code and someone designed the patch, therefore we are protected, when we have seen the evidence that we are quite wrong, and that we have to take good account of what we're actually doing in our systems with these controls. And for that organisation, oh my gosh, the harm was big, right? Significant. In fact, didn't we see the CEO go in that instance? Right, which is possibly the first time we've seen that. And so that's where we got to, if you like, with model. And obviously, we are thinking about and studying our peers in the community. We are looking for evidence that we can plug in terms of the effectiveness of controls. We are talking about how we use thematic coding of focus groups and triangulation, those kinds of methods, versus building widgets that can sit on the system, and what might that tell us about what's really happening. And as we go, we're looking for other scenarios to cut our teeth on. And what I show you behind me now is actually a scenario that Deloitte have been working on, which is, we understand, a synthetic scenario, and they are proposing a situation, a US health insurer scenario, where actually there is a single incident being discussed, which involves two distinct things. One is the theft of a laptop and accessing all of the data on it, and then within 4 days, I believe the scenario says, other things are occurring on the system, lots of new user accounts being created, and then there's another extraction of about another 1 million data records. It's a hypothetical scenario. What the curves behind you are designed to talk about is the cost, the consequence of that attack taking place. And what they hypothesise, we believe, because we don't know exactly where these numbers and these curves came from, but there's 3 phases that they identify in terms of loss and consequence. The little one at the beginning, this is the initial incident triage. So this is all the resource you deploy once you've realised something bad's happened. And there's lots of different activities. So breach notification, talking to your customers, trying to work out what you might have lost, etc., etc. And then there's a broader blue curve, which is just getting over the impact management. So this is where your PR and your comms will come into play, and the costs start to rise. And then there's a very long, not as peaky, but very drawn out curve, which is the long-term consequence as they see it. And this is being proposed as a, don't worry, you don't have to read it, but it's there for you after the event. This is the detail, an abstraction of the detail that you can pull out of that example. Now, the medium to long-term impacts that they talk about are linked to loss of customers due to reputation, and also a higher borrowing cost. And this is kind of interesting, the delay of the strategic acquisition. Now, during the various phases of our research, not just related to this project, but to others, we have been collecting cases and knowledge about what happens inside organisations and what's been going on. And this is not the first time, and we've seen real examples of business consequence at that level. In fact, there was one firm that we know of that suffered such a significant insider attack that was found, unfortunately for them, by their auditors, which stored the production of accounts, and because they were global, had a knock-on consequence where other operations in other countries were then investigated. It then stalled their production of the accounts, that caused a consequence that they could no longer trade on one of the big trading environments. That's the kind of harm that's incredibly detrimental to an organisation. It was that cost of seas of trading was much bigger than, in this case, the lost stolen technology assets that had been caused by the initial attack. So we started plugging in the Deloitte one into our model, and this is where we got to. And I put it on the wall, not for you to read it, but so you can see that even in this oversimplified world of a hypothetical scenario with very limited knowledge, and so we put in a few assumptions about what kinds of function they may have to have in that organisation. We can certainly talk about the controls that are mentioned as you read through the scenario. We start bringing them all together, and we started thinking about how we actually model all of the different parts. So this is the simplified version for a simplified scenario. But what it does do is it begins to bring all of the different components together. And so then we can calculate a value at risk. And what we did, because we don't have great data on the risk controls that are actually used, down here, so we have access controls, recovery processes, physical security on the portable devices, account monitoring and some maintenance pieces. There is no great data around what that can do. We started thinking about them in a very simplistic way, like one normally does, high, medium, low, right? So we have good, average and poor effectiveness inside our model. So this is the CVAR results, assuming that all of the controls in that organisation have the same level of effectiveness. So it's a sweeping assumption. We're saying if you're generally good at doing this stuff, you'll be good at doing all 5 of them. And these are the results. And I can tell you now that the numbers say to you, in the worst case scenario, assuming poor control effectiveness, then sitting at the 95% probability line that something's going to happen, then the losses are around 2 billion. And assuming good control effectiveness in this model, the losses are about half that. But if you look at the annual revenue of that organisation, that's affordable to them. So where would you go with this kind of information? Well, first of all, before I try and broaden it out, you could say this, couldn't you? If an organisation could construct a model that they believe in and that really truly represents their assets and their practice, and that we as a community could develop the insight and the data to really understand how our controls are how they affect things in light of practice, then you could construct these kinds of answers. And the kind of decision you might make as an organisation is this: well, we don't know for sure how well our teams are doing. Maybe that we think they're the best, we're employing the best people. The range of bad stuff we appear to be exposed to in the face of doing all of the best practice is somewhere between 1 and 2 billion for one of these events. And our insurers want to charge us $1 billion, let's say. So we could say, well, we might be bad. So what do? Do we spend $1 billion more on increasing our cybersecurity and hope that the outcome takes us down to the lower potential value at risk? We benefit from the increased cybersecurity, don't we, in general? I mean, this might not happen to us, for example. Or do we pay it to the insurance and say we're covering that space? And this is an ongoing project for us. But I wanted to conclude with this, and this observation, which is why I think it's important to this environment and this conference, is if we witness a coordinated attack where we have multiple organisations practicing the same kinds of risk control usage, employing the same kinds of people, thinking the same kinds of way, then they will be exposed to similar kinds of residual value at risk. And they may well have the same attack surface. And so one of the interesting ways we could take this work forward is to lift this out of a single organisation and say, what does this look like for a sector or a supply chain? But more than that, of course, we've tried to be as broad as we can when we think about harms, organisational harm. But undoubtedly, if you just think about the world in which we're living right now, it says to me that cybersecurity is changing, and it's changing fast. Right now, we still have the benefit of the kinds of requirements that we are asked to deliver on are still focused very heavily, aren't they, on stuff that we know quite well as a community. Data, tech, architectures. They're challenging. It's not true you know where your boundaries are anymore. It's not, you couldn't draw a line around it. There's no physical perimeter, but nevertheless, that's the space we've been working on in some time. But it's as you see how cyber has become so integral and not separate to humanity. We are cyber and physical as one now. And so now people are talking about harms to do with democracies. They will be talking about psychological harms to do with people and kids. And they're going to be asking of us as a community, well, surely cybersecurity is there to protect my assets in cyberspace. Well, my understanding of assets in cyberspace is changing quickly. And so we have to, do we not, need to broaden out our view, all of us, in terms of what is it that we need situational awareness on? What are the actors that we should be really concerning ourselves with? And what are the cybersecurity requirements coming together? And just to finish, it's not so far away that we will have to think about all of these controls in the face of autonomous synthetic beings. I'm not going to call them AI, but nevertheless, the investment that's going on in machine learning all around us, and has been for a couple of years, is giving birth to more autonomous synthetic stuff. And that stuff will be active in cyberspace. That stuff may be the source of harm and may be the source of risk. And understanding what on earth your options are, how you detect it, what does it look like to be resilient in the face of it? Can you take it down? Can you take it out of your systems? What if it's got lateral movement on turbo and it's replicated everywhere? And what's the consequence? And how is it interacting with our people? Is it already partly there? And all of those kinds of challenges, none of us have begun to factor into some of our debates. And I guess, taking liberties as a keynote speaker, what I wanted to say to you today is we feel very passionately that we must be doing better with this glue and that we have to come together to put rigour into it. And for that, we want more data, and we would like to work with anyone who's interested in generating that kind of insight. And then I think the challenge to all of us is to stop being complacent about the world around us. Because one thing is for sure, if you look at our best international standards and all of the controls that we are reasoning about and talking about improving, none of them are thinking about this kind of future, and yet it is coming. Thank you.